All right, so here's a video key of today's homework. So the first part is rewriting. Okay, it's in logarithmic form. Can we rewrite it in exponential form? So you don't have to solve anything. All the numbers are already there. We're just rewriting. All right, so comes from the definition. So we read this: log base 3 of 27 equals 3. All right, and so what I tried to stress in today's lesson was that a log is an exponent. So whatever's on the other side of the equal sign is the exponent. We're telling you what the base is, log base 3. So the base is 3, the exponent is 3, and it's going to equal 27. All right, and we just go through that and do that for all 8 of these. Okay, so we have 4 to the third equals 64. We have 6 to the second equals 36. We have 5 to the negative second equals 1 over 25. We have 3 to the x equals 81. Now, if we were solving, that would be 4. 3 to the fourth is 81. We're not solving, we're just rewriting. Okay, this is x to the third equals 8. We're solving there. X would be 2. And then here is 6 to the fifth equals x. And we just type that into our calculator. Relatively large number. And then here, 5 to the negative third equals 1 over x. And x would have been 125 there if we were solving. All right, so now we're doing the same thing, but vice versa. So now they're giving us the exponential equation, and we're rewriting it in logarithmic form. All right, so it's log base. And so when you write the base, it's like a subscript. The base is 5. So log base 5 of whatever the answer was. And I like to put it in parentheses. It's a good habit because once you start getting operations in there, it's important. Equals 4. It always equals the exponent. Okay, so number 10 will be log base 7 of 49 equals 2. Log base 1/9 of 1 over 81 equals 2. Log base 13 of 169 equals 2. Log base x of 16 equals 4. Log base 64 of 4 equals x. Log base 6 of 1296 equals x. And then log base 1/7 of 49 equals x. So if you just take a quick look at all those, right, whatever the exponent was, that's what's on the other side of the equal sign, right? 4, 4, 2, 2, 2, 2, 2, 2, 4, 4, x, 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 x. Right, whatever that exponent is, that's what the log is equaling. The base is always the base. The base of the exponential becomes the base of the log. And it's easy to rewrite. All right, so now just evaluate without using a calculator. All right, so they want to know, so 3 to the what power equals 81. All right, we'll kind of just send this equal to x. What's that x? So, right, 3 to the what power equals 81. And so your goal is to try to get these bases the same. So 81 is 3 to the fourth. So x equals 4. And so that's what we just go through And we solve for all these. And then, so 1 over 64, if we're writing that as the same base, that's 8 to the negative second. So x is negative 2. And this one, right, if this number is 1 right here, then it's always just 0. Right, 6, I mean, it doesn't matter what the base is. The base could be an x, right? It's anything raised to the 0 equals 1. So that answer is just 0. All right, and then so this one, there was a little formula in our notes today. All right, right, if that base is the same as that base, it's just the exponent, but it should make sense, right? If I call that x, then saying 5 to the x equals 5 to the 4th, these bases are already the same, so x just equals 4. All right, so 21, 2 to the x equals 1 over 8, which is 2 to the negative third. X equals negative 3. All right, so just like here with number 20, that answer is just going to be negative 1/2. All right, 23 is kind of a trick here. 23, it's no solution. You can't evaluate, does not exist. Because no matter what, 5 to nothing equals negative 25. You can't change the signs. So that's just that it does not exist. All right, 0.25, another way to write that's 1/4, right? So that's saying 4 to the x equals 1/4, all right, which we just write as 4 to the negative first. So x is just negative 1. All right, and so now remember when there's no base there, it's the common log, that's base 10. All right, so that's saying 10 to the what power equals 0.1. 0.1 is just 1/10. Okay, and so again, that's going to be negative 1. 3 to the what power equals 1 over 27. Yeah, I think 27 is 3 cubed, so that's 3 to the negative third. So x equals negative 3. And then this is a good one here. I like this one. Okay, so it's 81 to the what power equals, that looks like a 4. Erase that. Erase that. Eraser. It's an x. 81. 81 to the. I can't. Why can't I? There we go. 81 to the x equals 9. And so for this one, like if you don't recognize it, right, well, it's the square root, so it's going to be 1/2. But you could, again, write this as the same base, right? So you could go 9 squared to the x equals 9 to the first. And so now you get 2x equals 1. Divide both sides by 2, so x equals 1/2. Right? Or if you notice, okay, that's just the square root of 81, and we just learned how to write the square root using exponents, and that's the 1/2 power. And then over here, so last one, I think it's the last one. Yeah, 2 to the what power equals 1 over 64. And so 64 is 2 to the 6th. So that's 2 to the negative 6. So x equals negative 6. And there you go. That's how you're going to write it. Again, right? If you know your powers, you know your first few exponents to the third power to fourth power, know your base twos. These should all be pretty easy to do without a calculator. All right.